Thank you, sir. For further deliberations, I request the chair of the session to kindly take over the session.
Distinguished guests, ladies and gentlemen, let me chair this session for the managing risks in key infrastructure sectors, disaster control infrastructure. So we have so far had an inaugural session and also the previous session. This overall provides the framework of the various disaster risk reduction efforts. And also the last session focused on how the Indian perspectives, particularly National Disaster Management Authority. So this session purpose is really to look at what we are really doing, looking at country experience and some of the case studies. And we also here have a Japanese experience who also took the lead for setting out Sendai framework and also setting out key indicators, guiding principles, and the priority actions, including building back better concept. So this session has several key questions to be looked into. Number one, how is the disaster control infrastructure is planned? And how, in that context, climate change is taken into account. Question number two, how is disaster control infrastructure maintained, operated, and upgraded over time? Can it be made multifunctional in order to serve other financing functions during the fair weather conditions? Number three, how does this introduction of disaster control infrastructure affects the exposure and vulnerability profile of the region over time? So we tend to focus in the past on a single purpose infrastructure, but gradually extended our scope for integrated approach. Number four, how is risk communicated to the communities? How community responded and managed the risks? And lastly, how can financing for climate change be tapped for structural and non-structural resilience? So this was extensively covered in the last session. Junaid has taken a very inspiring discussion. So we have 5 presentations here, which is to be followed by discussions and questions. Then I'd like to invite the first presenter, Mr. Cees van den Guchte. He will share experience of the Netherlands with regards to its long history with disaster control infrastructure. Based on this experience, he will talk about acceptable risk, the use of scenarios and policy analysis, decision support, build back better, participatory planning, process for engagement with the community associated with cost-benefit analysis, risk assessment. So Junaid was also explaining about his experience and the fascinating approach already taken in the Netherlands. So Mr. Van den Guchte.
Thank you for your kind introduction. Yes, my name is Cees van den Guchte, working with a knowledge institute, which is the primary knowledge provider to our government, also on disaster risk reduction next to water management. You may have noticed already my genes have adapted a little bit to envisage sea level rise, so I will stand flat a little bit longer than the average population I see around me. I will quickly go through slides. If I go too quickly, you may read them afterwards. I will tell something about flood protection and disaster control infrastructure, protective measures in the Netherlands. The Dutch Delta program is a good example for that, we believe. It's taken a prevention approach, and it's assuming much of collaborative effort, much of dialogue between many different stakeholders, and integrated approaches to the system we live in, river basins and coastal areas. It fits into the national risk profile, and we have some complementary mechanisms. The messages I will come back to at a later stage, but we believe that investment in preventive measures for flood risk reduction, it pays back and is at a reasonable cost compared to our gross domestic product. The Netherlands, in a small country in the Netherlands, is the confluence of 4 major transboundary rivers in that area. This country is for 2/3 below sea level and flood prone. That's why dealing with floods is a national policy, is a policy at the national level. We have had history for long, of course, also in facing disasters and storm surges, and we lost quite a number of villages in the time that the Netherlands was not so well protected as it is now. This protection, it's emerged working together with water boards who took care of the governance and the joint work on developing polders, of which we have in this small country already 3,000, which is half of the number of polders created in Europe. After the floods of 1953, it needed a disaster, yes, to have a high political commitment to bring it to the national level policy. We had a Delta Commission which said, our ministers, we have to protect ourselves better jointly. We want to shorten our coastline so to be less vulnerable. We at the same time want to secure food production in a good way. We want to transport for our economic activities over the water routes, and we want to be connected to the road networks. We then built a number of large infrastructure developments, large barriers in the major estuaries. We have some 5 of them, and we spent at the initial phase some 4% of our gross domestic product to it. When a wake-up call came with Al Gore stating that the climate change impacts might certainly also influence the Netherlands, jointly with the IPCC studies, envisaged higher storm surges, higher river discharges, more floods, more heavy rainfall as the most water-related issues to face in the coming times. Of course, there was a lot of uncertainty also, and it still is, in how this will develop over time. Many scenarios for possible sea level rise in the Netherlands. The concerns from our Netherlands government was not only the safety from our country, but also a safe climate for foreign investors to invest in our country. So we took all those drivers and challenges and combined our knowledge to provide advice on how to deal with it. It's water coming from different sides and dealing with demographic developments and climate change impacts. We set objectives for our policies, and then we installed a new Delta Commission. Well embedded in the political setting, we had a champion, which was the Delta Commissioner. He was independent from our political debates. So also was our fund that is created. It's not in the daily debates on financing and the yearly debates. We have an annual program to make decisions on how to come to resilient infrastructure, and we have embedded that into national law. Working on those deltas, it has several reports which you may find in the minutes of this meeting. Part of that is an economic analysis ex ante to develop a good decision-making framework for investments. Investments in preventive infrastructure. We started in developing a system on what do we want to protect and what is our value, what is our vision on the value we want to protect in developing risk-based flood protection standards. The same methodology we used for making choices in investments. It's about how much to invest, minimizing both the total of investments itself and also expected damages and casualties to be reduced. A dynamic pathway, which is supposed to have a system approach in acting now with a long-term vision, it again makes a more adaptive type of cost-benefit analysis possible. We did a lot of work on that. We did run many scenarios on a possible impact of floods for about 2, 4, or 5% of our gross domestic public, and we calculated risk to that. We did have a system of probabilities that we wanted to protect in different regions of the world, but of different regions of the Netherlands, but they were not thought to be good in addressing a common basis, which should be risk-based, we now thought. So then we revised our system on flood probabilities into a system based on risks to be accepted, based on a casualty incidence of 1 extra death per 100,000 inhabitants. Well, the older system was supposed not to be good enough. This risk-based, we think, is much better to have a coherent and resilient system. And we think that the cost-benefit analysis may help to have an optimization in the investments to be made on the level that you want to protect. We also can maintain this level of safety with only 0.2 or 0.4 percentage of our gross domestic product. We base it in climate scenarios and also to have more robust decisions for resilient infrastructure to be developed over the longer term period. And we think that we managed well in addressing those in providing guidance for action now with a long-term vision on possible futures. The many stakeholders involved, they make it a long time process to develop a new system of safety levels. But we also think that the independent nature of our Delta program and commissioner and fund very much helps to keep it alive in the political settings. I have 2 examples to shortly show, which is addressing also nature-based solutions here to give room to the river in the floodplains of the River Rhine, to enable higher discharges in the River Rhine, co-benefits through land reclamation and real estate and other activities, they may help in bridging the funding gap. The same about another project carried out by having a soft dike along the coast of one of the islands in the Netherlands. And here the co-benefits were also seen in ecological values. However, it seems to be quite difficult again and again to attract non-public funds for nature-based solutions in flood risk reduction. And that's where we seek further, also in collaboration with the World Bank and with the Asian Development Bank and many other actors, in guidance on how to proceed in leveraging private sector funds for such type of infrastructure. This system of developing safe levels of protection for floods and the infrastructure to it is embedded in a wider national strategy on national risks, our national risk profile, for which we also assess on a regular basis the needed capabilities. It's about territorial security and economic security. It's about national risk assessment, which we have compiled in a national risk profile. I don't know if you can read it from that distance, but you may notice that floods from rivers and sea, they are seriously looked at, but we expect more impact at the short term from cyber issues and from animal diseases that may flee our country. And it's because we think we have, with our risk management on floods, we have a rather safe system in place at the moment. We think it's an essential step in addressing how to meet the needed capabilities, capacities to deal with the levels that we want to secure. The Delta program and its infrastructure development is in place, but next to that we also take care of spatial planning and land use planning. in addition to building infrastructure. And of course, we have in place a disaster management contingency plan, which comprises evacuations and the modalities to act, taking into account the needed infrastructure which should be in place at that moment as well, and should be flood-proof, resilient, and climate sure. Flood insurance is not so much an issue in our country, because we have addressed this through taxes in our national tax system with the water boards, where we pay for flood resilient infrastructure at the national level. We think that, well, in insurance it may help to share risks, and it may be an incentive to reduce risks, but we think that at this level of common infrastructure at the national level, we think we are better off with having a national tax system to pay for it. We have complementary work which is essential for a good implementation of resilient infrastructure. I have listed here a number of them, which includes early warning systems, addressing impact-based forecasting. It's about contingency plans and response teams ready in case needed. It's about communication to the actors in the field, but also to the wider public, that they are aware of the risk and about residual risks and what they can do to help themselves. We do address infrastructure stress testing, looking into how much can it have before it fails regarding climate change scenarios, tipping point analysis, and we look into cascading effects of failure of such mechanism as to have a proper incentive and direction on decisions to further invest in infrastructure and retrofitting. For that we use a pathway analysis where we try to focus on short-term measures to be taken immediately and at the short term, but all the time with long-term vision in mind, addressing climate change impacts and possible disaster risk reduction agendas. We do so not alone, of course, in the Netherlands. We do it jointly with our neighbor countries from upstream in the River Rhine and the River Meuse and the River Scheldt. And we work together at the European level with the European flood risk, the European Flood Directive, transboundary management, early warning systems which are installed European-wide. We strive very much to open data and information for all involved. My last slide captures more or less what I tried to convey with you also. I put it in my first slide already. In the Netherlands, because of this preventive approach, disaster risk reduction and related disaster control infrastructure is very much aligned with measures proposed for climate adaptation. And in the planning, we try to align those as much as possible. We think that prevention in disaster risk reduction and control infrastructure pays off very well. 2, 6, 10-fold maybe in avoided losses, but still avoided losses are not a cash flow to those that have to invest, and that may be an issue to be addressed further in innovative type of financing and blended mechanisms to address this. We believe that some further guidance, as already mentioned earlier, this knowledge network, knowledge infrastructure and experience infrastructure could be very helpful to share experiences and to further develop such guidances. Thank you very much for your attention.
Thank you very much, Mr. Van de Guchte. So I think the Netherlands case is a quite advanced example of making multiple goals set, and also I think there's a high political attention and drive and political ownership, so something that we may learn from their experience. The next presenter is engineer A.B.Pandya, who is a long-time Secretary General of International Commission for Irrigation and Drainage. And he will make a presentation on operation and maintenance issues in water resources infrastructure, dams, reservoirs, and drains, and challenges in setting standards and aligning with the international standards. Mr. Pandya, please.
Thank you, Chair, and distinguished gathering over here on the dais and off the dais. The disaster control infrastructure, the role of water resources structures is something that cannot be really ignored. In fact, they become the prime disaster control infrastructure when we have to look at the disasters which are primarily related to the water. And water, by way of floods and by way of even droughts, also become a very major factor which can ameliorate a disaster as well as which can also create a disaster if left untamed. The primary area in a monsoon-fed country like ours is the water conservation, and water conservation gets linked with the disaster management in form of the flood management and flood control. And that has been the right from the beginning of the start of our coordinated development from independence onwards, the multipurpose projects where flood management has been one of the major issues, has been the prime target for the development. Primarily, we have the disaster control from the water point of view is the dams of various sizes and embankments for flood protection. These two are, of course, two different entities. Many times in many of the other ancillary fora, the flood embankments and the dams are put under the same category, but they are really not so. They have to be treated slightly separately. Erosion protection measures also provide sizable protection against the disasters. Apart from the embankments, there are other erosion control measures which also give you a lot of benefit in managing the disasters. The associated systems are also there, which provide for the flood forecasting and monitoring so that the advance warnings are given. For example, the Central Water Commission has been operating a flood forecasting network all across the country for providing the flood warnings in respect of the interstate rivers. And this flood forecasting becomes a very, very important topic because you are able to get advance warnings of the likely submergence that is to occur and whatever other problems that are to occur. As far as dams are concerned, we have about 5,100 large dams. The large dam is a dam which is having a particular characteristics, and that is why it is called a large dam. Even though, of course, many other dams do also perform some amount of disaster control, but then primarily this large dam definition is the one which creates a structure which is capable of giving you some relief or some management of the infrastructure from the disaster point of view. The smaller dams, generally what happens is that they don't have any capacity, and because they don't have capacity, they start flowing, they start overtopping right from the initial floods period itself, and then very little moderation of the flood peak is provided. So those dams are largely not considered as a kind of a disaster control infrastructure. We have various sizes of dams depending upon the requirements, and the higher height dams are largely capable of managing and giving a substantial kind of a disaster reduction and a disaster management from the floods point of view. Whereas smaller dams do provide some amount of facilities, especially for regulating the flows and providing a local kind of flood management. We have various types of dams, and in each type of dam, there are specific issues that has to be really carefully looked into, and specific issues that have to be managed in order to see that the dam is capable of performing that disaster control infrastructure function and not becoming a hazard in itself. For that purpose, we have a very extensive dam safety program. Under this dam safety program, we are maintaining and we are trying to look at the safety of all the large dams across the country, wherein whatever problems of operation or management that are coming up by way of strengthening their capacities and by way of strengthening their performance is brought in. Currently also there is a World Bank funded program going on in the name of Dam Rehabilitation and Improvement Project. Earlier also we had the similar kind of programs. The most important thing about the dams is that the dams have to really perform a disaster control function for almost an indefinite period after they are commissioned. And for that purpose, over the period of time, there are many issues that crop up. For example, when you build a dam, you have got a particular type of database on which you based your assumptions, and based on that you build the capacities of the dam towards the spillway, etc. And then when it comes to a performance review after, let's say, 20 years, 30 years, and so on, then because of the additional phenomena that have been noticed, you have to have some additional factors that has to be built into the dam in order to see that the additional flood risks that the dam is posed with are also handled by the dam in an efficient and in a proper manner. Many times in the general kind of parlance, especially at the local local press level parlance, it is always said that the dams are the ones who create floods. So there can be nothing farther than this. The dams never create floods. The floods are the natural phenomena which happen, and then it is the dams who are able to control it, and they are able to really manage them. But then many times this kind of an issue comes up, and this issue is more so when over a long period of time the area has not experienced the floods, and then suddenly some floods come, and at that time you have to operate the dam in the manner that it was really designed. And at that time this kind of an issue really comes up. But then it is very important to know that the kind of disaster control in the floods is provided by the dams, especially large dams, is kind of unmatched. Only one issue that we have to really very carefully look at is that, for example, we have got a very large number of earth dams. The earth dams are something which are very sensitive to overtopping, and any overtopping almost leads to the dam failure, which may create a much bigger disaster than the main flood itself. And for that matter, we have to be very careful about their operation. We have to see that the flood handling capacities of these dams are adequately taken care of, and they are managed well. The issue is that another issue that also I want to bring about is that many times at least in Indian papers, the barrages are also awarded unwittingly the disaster control functions. Again, the barrages are quite different from the dams, and they do not control the floods because they do not have capacity to control the floods. They have never been designed for that. The barrage is a diversion structure which only tries to divide the flow of the river between the diversion canals and the main river. And really speaking, it has no ponding capacity in order to really manage the floods. But then many times in the disaster control kind of parlance, it is told that the barrage has released so much water. Really speaking, barrage really doesn't have any capacity to store, so it doesn't have any capacity to really release extra. So from that angle, we have to be slightly careful when we look at the situation where we have to do the disaster control from the dams. They have to be well engineered. This is something which is assuming a lot of importance in the view of many of the criteria that get adopted for building a dam. There are a number of places I have observed that the standards that are existing do not really cater to the proper kind of development and management of a dam. And since the standards do not exist, some kind of other standards or some kind of other issues that are brought in, and in the process we may be having a dam which will be not having adequate capacity for the disaster control. So from the design's point of view, it is very important to know that what are the kind of flood risks that the dam is likely to face, and then how that dam is going to respond to it so that it doesn't become an additional hazard, but it actually provides you with a disaster control kind of thing. The another issue that in the disaster control infrastructure, especially dams and hydromechanical structures are concerned, is the maintenance and management of the dam. Dams are generally nowadays, almost all modern dams are provided with the gates which have to be operated mechanically, and these gates are the prime instruments for the disaster control, and simultaneously they also become a prime kind of a cause for creating some kind of a problems if they are not maintained properly. These maintenance issues have to be really looked at from the even from the disaster management point of view also. Right now we are looking at these issues mainly from the purely dam maintenance issues, but and because of the risk that they pose to the dam itself. But then this has to be looked at from this point of view, that how the disaster control functions will be affected if these maintenance are not really attended to in proper time. Another very major issue of making the dam very efficient disaster control infrastructure is the capacity building of the operating staff is there. Because the floods do not happen every time. Floods have some kind of a frequency, but then they are a random phenomena. They occur at any given point of time, or they may not occur for a very, very long period of time. So the people who are in the charge of managing the dams, they keep on changing because of various reasons. There are people who will retire, there are people who will get transferred. And the person at the point when this kind of a situation occurs has to have complete capability to manage that situation in the most efficient manner, with some amount of advice, of course, from the higher level of authorities. But the person at the site has to have the maximum kind of a responsibility on that. And for that, the capacity building of flood handling is something that gets very important. To my mind, very few locations are there in the country where some kind of a exercise is kind of performed every year in order to see that the people have the adequate capacities and they have the proper understanding. But then in many of the medium-sized dams and many of these kind of dams, the capacity of the personnel becomes a very important issue, because if they do not have the capacity, then the response may not be proper, and the disaster control function may not really happen very well. Another issue with the disaster control function of the dams that we have to really address is the encroachments in the river channel and over the embankments. This is a very serious problem that we need to really look at. In a very highly densely populated country like ours, whenever we build a dam, for the initial period of time, for quite some period of time, you have got additional areas that get exposed in the river channel, which are actually part of the floodplain, and they have to remain as a part of the floodplain in order to maintain and manage the river channel hydraulics. But they become exposed and they become available for developments. And once these developments take place, then they come under increasing threat when you have to do a design operation from the dam. And in the process, the problem that occurs is that the disaster control function of the dam gets severely hampered, because you impose arbitrary constraints on the dam, which starts becoming a hazard to the existence of the dam itself. And these problems have to be really tackled at the land management level and at the disaster management level, where any kind of new developments that are taking place around the river channels have to be very severely and very systematically regulated. If they are not regulated, we will end up in a situation. I'll talk about that in this one. Like, we have got excellent disaster management systems when we planned them. For example, the Damodar Valley system, which was planned in 1950s. It used to be called Soro of West Bengal. And with this system, almost the majority of the floods were eliminated. And in top of that, because of the conserved water, almost 9 lakh acres of land started getting irrigation almost in 3 seasons a year, and the entire area became a football. But then what happens? Over the period of time, when we designed these dams, it was understood that we will be able to release about 250,000 cusecs on any given year as a part of the flood control exercise, where we'll arrest the flood, but then we can release that much, and the channel will be able to really take that much flood without really creating any damage. And now, after about, say, 50 years or so, the situation is that even 100,000 cusecs is being resisted. There are all kinds of, political problems on the dam managers that you should not release this water. Now, what do you do with this? The issue is that the land management downstream is an integral part of the disaster control function of a dam. And if these two are disconnected, then this disconnection really leads to so much problems. And in fact, it leads to so many disasters which are actually imminently preventable. And we need to really look at that. Similar is the case where you look at this, this Ukai Dam project. Ukai Dam project was specifically built for protecting the Surat town and the surrounding urban, highly valued urban developments from floods. And for that, it was also expected that about 600,000 cusecs will be capable of being discharged through the Tapi River after this dam has been built, so that the floods will be eliminated from the Surat town. It did got eliminated, but then with the encroachment in the river channel, now that 600,000 is long gone, and you have issues when even 100,000 and 200,000 kind of cusecs releases are required. The dam manager really is at his wit's end that how to do it. Many times you have to really actually waste the water in order to see that this kind of situation doesn't occur. So from this angle, we have a very strong measure in form of dams for doing the disaster control. And then simultaneously, if the entire system is not managed well, then the lopsided operations will actually end up creating some kind of additional hazards in addition to the, providing you with a very valued kind of a disaster control function. Other projects, they have been doing rather well. For example, Tehri Dam, if you look at the 2013 disaster of Uttarakhand, the disaster would have got doubled had Tehri Dam not been there. Because of the Tehri Dam, we were completely able to absorb the floods that were coming from the Bhagirathi branch of the Ganga River, and only the Alaknanda branch, which was not having any storage structure and which was not having any control structure, only provided the floods downstream. Otherwise, had we got two such projects on both the arms of the river, we would have been in a position to completely proof the Rishikesh and Haridwar and all the downstream areas from the floods. So from that angle, we have a very valued kind of a measure available in the disaster control functions, and we need to really work very systematically on these functions. And I believe that not only the dam operators have to have the capacity to understand the operation and manage the operation, but also the disaster management personnel should also have that capacity in order to understand that how the management of the dam will take place in the event of a flood, so that when there is a communication between the two authorities or between the two entities, then those entities are able to really
Pandya,
communicate
Mr.
well.
Pandya,
Thank you very much for
you said the last slide
Yeah,
included
you would like to
conclusion. So yeah, just a reminder. So
yeah.
So I think thank you very
so
much
now my presentation is over.
Yeah,
So thank you very much.
Yeah, thank you very much. So this is India water resources perspectives. We have a next presentation by Professor Takeya Kimio, who is he's an advisor to Japanese Prime Minister's office and also a key drafter of Sendai framework, and he is also representing Japanese government in various international forums on disaster risk management. So we'll be hearing from Japanese perspectives. Thank you.
Thank you very much for ladies and gentlemen. My name is Takeya, and I'm from Japan International Cooperation Agency. And as introduced, I'm the main negotiator from the Japanese government for the Sendai framework, spending 1 year in Geneva, together with Andrew Musgrave, set up the very nice, perfect document together. I believe this document can be the Bible for the next 15 years DR investment. But by this time, I want to explain about the request from the disaster control infrastructure in Japan. And this experience can be mobilized to your country, I believe, definitely. So usually your prime minister or someone or your ministry irrigation will, as irrigation gentleman said, that they make the levee and reservoir system and they set some target. In the beginning of the flood control, we never set the target level, design target level. We just try to keep the high density urban area and so on, and make the barrage. Sometimes barrage has no function to store the flood, but sometimes like an industry upstream barrage control the water and make the good effect to downstream and levee and also. So usually like this is industry bar. But anyhow, usually we build structure measures as a basic infrastructure, and non-structure measure also build up like a second stories rooms. Usually reforesting upstream, appropriate land use, flood-proof lifestyling like a Mekong River, or flood forecasting for Bangladesh to harvest already 80% crops is getting up, but the once flooded 100% disappear, but before a flood you can harvest it. And early warning for evacuation people, and evacuation and insurance for the social support, and also business continuity plan for the mega industrial park and so on. So basic structure is control, protection and prevention, and the risk mitigation, avoidance, transfer. Everything must be fit to your country's condition and safe and or resilient. So I strongly want to say later the difference between safe or strongness or resilient. So Japanese experience led back to why Japan can dedicate on disaster risk reduction. Maybe you don't know, more than 50% of people living in floodplain, more than 75% of whole asset of Japan located in floodplain. So this is our country's key survival issue, to make DRR to our country's development. Usually, normal development usually obstructed by the disaster, and try to recover quickly, but within several years, extensive event happen around here and there. So the GDP of our ideal plan was dropped down. So how to fill this gap of original economic countries' development plan and the natural disaster obstructed development? This is the point of the main Sendai framework. So usually in Japan, we believe that three components is important for disaster risk reduction and management. One is self-support or self-defense by individuals, and mutual support by the community, and the public support from the government. So these three items depends on each hazardous types. If you talk about earthquake, you must emphasize the people to strengthen their own houses. If you talk about the flood, the government public investment for the levee or reservoir system can protect whole area of the downstream flooded inundation areas. So you must think about everything. Depends on what kind of disaster or what kind of hazard you are talking. So even in Japan, one of the main river, Tone River, just go down to Tokyo more than 400 years ago. But at that time, even the shogun, samurai era, shogun decided to divert this biggest river, not directly down to Tokyo, but to another part, in order to protect Tokyo from the inundation. So by this long 400 years ago investment, we enjoy Tokyo status now. So even after the World War II, Ise typhoon, one of the biggest typhoon like Yolanda, Philippines, almost same level of the Yolanda happened in Japan in 1959. More than 5,000 people died. At that time, almost same magnitude. This is the situation of Japan at the time. We were very poor after the World War II. Still we are very poor, but later I will explain. After the flood, after the typhoon hit, we decided land use plan, we changed the building code to protect, lead the guidance to protect, to reducing another new risk in this area. This area is Nagoya, and Toyota headquarters is located here. So this kind of governance or institutional issue can save for the future disaster. And usually, as I said, or I'm sorry, already I explained, JICA, and also in order to convince your Minister of Finance or Prime Minister how DRR investment is good for future development, we produced macroeconomic model named the DRAD model. DRAD means Disaster Risk Reduction Account for Development. That means in Pakistan case, for the future 30 years, if Pakistan government do nothing for the DRR, GDP will drop down as a past experience simultaneously happen for the future 40 years, GDP will drop down more than 25%. This is very robust simulation, but it was listed in the Global Assessment Report in 2013, and that as a macroeconomic model case. So this model makes discussion of Sendai framework from the humanitarian issue change to the development issue. This is most important. And I also, in Japan, we have 107 major river systems in Japan. So we design our river control, flood control system for 100 years to 200-year return period. You can see, this is downtown Tokyo. 4-meter depth below the water level. Millions people living there. So this is our survival issue. So how we conquered it? We, after the World War II, we spent more than 5 to 8% of the whole budget, of whole government budget to DRR. So government budget is almost around 10% of the GDP. We spend 10% of the government budget. That means we spend 1% of the whole GDP to DRR for 3 decades. By this, number of the fatality of the flood, number of the area inundated dramatically decreased. And we enjoy today's Japanese, how to say, economical development. So this is also listed in global assessment kindly by the Andrew Musgrave-san, that everyone can read about this case. And invest for which level? This is next discussion. Today's main discussion will be this. Think about target risk or natural force. For example, Sendai framework talk about 2 types of risk. One is existing risk. One is future risk. This is Sri Lanka case. Originally people living in the hillside, but by the economic growth, people want to intrude to the floodplain. So new risk or new damage will be happen by our activity itself, by the lack of governance or lack of land use planning. And one more thing is extensive event and intensive event. Extensive event at high frequency happen, small damage by each, but give the big body blow to the economic. And intensive event like a big earthquake and a tsunami like a Sumatra or Japan, low frequencies, but serious damage by one event. We must think about how to deal with these 2 things. So usually 2 types of hazard, usually extensive event can, in Japan case, must be protected by the structure measures. And then intensive event mitigate with additional non-structure measures. This is Japan's case. So the problem is how to define this borderline, make the structure measure investment or shift it to the non-structure, measures based on the, as I shown in the first story structure measure. You don't deny. You must do it first. Then you can go to the next. So threshold of the L1 force depends on each country's condition, mainly B by C, benefit by cost. So civil minimum, usually if we make the investment, today the total investment is very low, but within 10 years you try to convince your Minister of Finance and make investment. So protected risk zone will increase, but still there is some extensive event happen, so residual risk remain still. So how to deal with it? So this is another issue. Usually, this is the case of the Chao River, Thailand case. I made the master plan request from, at the time, the Prime Minister, that we propose that controlled inundation in upstream, in the farmland, will be happen. We cannot stop it. but the land use plan and the regulation and the minimum the damage and the reforesting upstream and build the new reservoir system and everything. And in the downtown Bangkok area, we must protect the flat band or flatway, and so divide it to resilient zone in upstream. Resilient means once accept the damage and recover quickly. But in the Bangkok area, metropolitan area, we cannot say resilient. Once flooded, every building stop the supply, water supply and everything, electricity supply, so metropolitan function completely destroyed. So every foreign investor will get out from Thailand. So we propose separate to safe zone and resilient zone. So we are talking about, very nervous about only talk about the resilient. So once again, this thing is already coming to the time. I will show one thing, not only the infrastructure, but also this is what Japan prepare for the earthquake. We prepare for earthquake like this magnitude. You can see, still the building is safe. And also, this is the real film of earthquake in 1959. This kind of magnitude of earthquake happened. We are preparing for this. And in order to, we found that our school is not so safe enough for this type of intensive event. So we cannot secure the student life. So we spent 15 years to make the retrofitting to the school almost 100% finished in the Sendai year. So, and one more thing, this is compared to our Japanese style earthquake, design earthquake, this is Nepal earthquake. Almost same convenience store, nothing for us, very soft shake, very small earthquake. But what happened? So by this kind of pancake crash happen, the education has no sense. First, public support, government must reinforce the school. Then you can talk about evacuation drill or something like that. So this kind of discussion is must be more logically discussed. So this is end of my presentation. Thank you for your attention.
Thank you, Professor Takeya. It's very insightful how Japan is policy making and investment plan making is really based on evidence and also integrated to implementation through foresight. So we have a video from UK experience in the next one. So from this is from Professor Jim Hall.
That is not working right now,
Working?
sir. You can use it.
So then I have a presentation provided from ADB headquarter colleagues. So just while waiting for this video, just let me make the presentation. So I have a brief presentation from ADB's experience. I briefly explained the level of risks in the urban areas and how ADB projects over the past years have adapted to the emerging requirements. So today, I think we are all aware that the level of risks of urban, particularly the Asia-Pacific population, is that more than half of urban residents in Asia-Pacific region live in so-called floodplains and low-lying coastal zones. So this includes major cities like Bangkok, Dhaka, Guangzhou, Ho Chi Minh City, Kolkata, Jakarta, and Manila. And this risk of disaster, particularly flood risk, is exacerbated by nowadays the climate change. And urban area particularly, the solution is quite complex. We have a social dimension and economic concerns, and also urban area is quite congested in many places. So holistic approach is the way that we have to move forward. In the past, as we all, I think several presenters already mentioned that we tend to focus on infrastructure, flood control structures, dams, embankments, levees, coastal embankments, and so on and so forth. And, protecting the risk of flooding, tsunami, so on, with this structural measure alone can be quite costly as the urban areas develop. And also with the same level of infrastructure, if you adapt to more risk reduction on the soft side, the same infrastructure can withstand much higher disaster risks. So over the years, we have been, and also IDB project has been adapting integrated approach of flood risk reduction. Then I think Mr. Takeya has also covered, we have to reduce flood hazard in the upstream level. Of course, infrastructure is a key component to mitigate the risks, but also at the same time, regulating land use, motivating people staying away from the flood risk zones, and also community awareness. Those are key areas that is increasingly reflected in the water-related disaster risk reduction activities. And ADB support, this is an example in Indonesia. Left-hand side is the conventional structural measures, but nowadays increasingly looking at the upstream side and data and also flood warning systems, catchment management, and then this can reinforce the effectiveness of structural intervention. And then downstream side land use zoning and community awareness can also further enhance the coping measures and the risks management systems. And this example of the flood risk management project in Indonesia, the photo shows the existing situation, but the adapted intervention includes institutional strengthening, planning and coordination of provincial district levels, and then flood forecasting, early warning systems as an essential tool to inform the people and start managing the risks. And then infrastructure, essential infrastructure, river dikes, spillways, coastal protection, and so on. And the community groups awareness. And ADB also is providing knowledge TA to collect the best practices and share information, and also promote policy level dialogues amongst the member countries. This slide shows the particular vulnerability of urban areas and challenges of urban areas. In the case of natural cover, a lot of the rainfall is absorbed into the ground, but since urban areas is paved, and so there's a very rapid runoff coming out. And also in many urban cities, the drainage is a single purpose drainage, not dividing sewerage channels used, and then there's much less capacity. So urban areas poses significant challenges. I think that's well known. And this next few slides shows a kind of most recent ideas, what's called sponge cities. So adapting various measures to absorb the water, not reducing the immediate runoffs, and try to control the flood damages. And here's a kind of conceptual layout using the, if the city is surrounded by big areas, then the water conservation, preservation areas can be prepared. And also a kind of spongy concept of porous design interventions to avoid the massive runoff from the rainfalls. And then here's a concept of a green roof and water saving recycling, the idea. So the last example is, this is a Chinese example, and I think Chinese government, I think participants from China already here, has already initiated this concept early 2000, I understand. And also this concept is also adopted in many countries in Europe, Asia, Japan, US, and so on. So particularly the issue is here an integrated rural-urban flood management, and then inadequate management of wastewater, solid waste, insufficient flood and environmental risk management is also all causing. And the idea of how this program is resolved is taking a very much a kind of integrated planning approach, and defining the urban areas, and showing the clear future kind of land use mapping, and also structural mapping, and also combining together with the building code, changes to ensure that the structures are built in a safe way. At the same time, some building regulations to allow high-rise buildings in the center areas, and other residential areas in the surrounding. And at the same time, doing a lot of water conservation planning to absorb rainfalls and the incoming waters in a manner to reduce the risks. And I think this concept of longer-term planning for integrated water-related disaster risk management can also have some implications for financial funding aspects. And I think India is already pioneering some cities like Ahmedabad and some Gujarat cities to try to undertake long-term planning and fully disaster-proof, and making the plan also including the change in the land use, changing the also building codes, and also attracting, capturing the land value in such a manner that eventually the investment will be paid back by the increased municipality property tax systems and land revenues. So in that sense, the idea, this example of this Xingyu Kong River watershed flood control project, 150 million recently approved, provides also one sample of good cases, and we have a website showing the project example. So these are some of the examples. Thank you very much for the attention.
Thank you for all the excellent presentations. With due permission of the chair, as fifth speaker, a recorded message of Professor Jim Hall, Environment Change Institute, University of Oxford, will be played.
Resilience and management of risks to infrastructure is of great interest to me, both from a research perspective and also as an advisor to the UK government. There's been a growing amount of concern about climate-related risks to infrastructure in the UK over the last now 10 years because of the effects of some extremely damaging events in 2007, 2014, 2015, which disrupted the electricity network and the railroad network and had wide-ranging economic impacts. In fact, weather-related incidents, as this analysis shows, are a significant proportion of all disruption on the road, rail networks, and electricity, high voltage distribution, and often these incidents are particularly severe and quite wide-ranging because of the spatial extent of climatic extremes. Following each of those incidents, there have been lessons learned reports, and government has been seeking to promote good practice in terms of identifying vulnerabilities, sharing information and then making sure that steps are taken to improve the resilience of the network. My own research group has been developing national scale models, both in the UK and indeed internationally with the World Bank, on looking at the location of infrastructure assets, how they're connected together in networks and hierarchies as this diagram depicts, and then taking flood hazard information and hazard information of other natural hazards, and identifying the scenarios in which the infrastructure might fail and what the consequences might be for other assets elsewhere in the network. Those are the ones which are coloured orange, and for all of the users, be they inside the floodplain or actually indirectly impacted because they're connected to infrastructure, even though they're not in the direct line of path of the hazard. We've developed that for all of the UK, not only for the electricity network, but also looking at the ports, airports, railway stations, water towers, wastewater treatment works, telecom masts that are connected to that network. And that enables us to identify vulnerabilities and prioritize interventions. But if interventions sometimes involve quite big investments, and so that requires quite careful cost-benefit analysis, which is what this graph is. The y-axis here is the net present value of investments to reduce the risks to electricity substations, and we've looked at 100 or so substations ranked on the x-axis in terms of their ordering importance. For there to be a positive business case to improve resilience, the net present value needs to be above 0, and the cheapest intervention, building a wall of the type shown here, is cost beneficial for every one of those substations. For a few of them, it's cost beneficial to raise the walls and also raise the assets inside the substation. We looked at relocation, and actually that's not cost beneficial for any of the substations we looked at. But if one's building new substations, it certainly makes sense to build in less exposed locations. Then, in advising government on the adaptation committee, we've kept an eye on how many of these works are actually being implemented. For the time being, not very many, but this is work in progress. And then we do the numbers on looking at how many people are at risk at present. That's the red bar. How many more people might be at risk in the future? And then looking at the planned program of adaptation and risk reduction, how much is that going to get risk down by? That's the green bar. And what we're interested in is what's the residual, what's the blue bar at the end, which still needs to be managed. Further policy will be needed to deal with that. On the adaptation committee, we use a red, orange, green, red and the green scoring system to report to Parliament on whether the utility sectors, as listed here, have plans to improve their resilience. It's not enough just to have a plan, they need to be doing something, are actions taking place. And then most importantly of all, are those actions actually reducing risk? And we can see there's action taking place in most of the sectors, but we're not completely convinced that that is actually being effective at getting the risk down to a manageable level. And in some areas, ports and airports, digital infrastructure, those assessments are coloured grey, and that means that we don't have enough information in order to make a good assessment. You can see how each of those pieces, which I quickly skip through, make up a risk management cycle in which we use our data and models to assess risks. We also use the same setup to appraise responses and come up with cost-effective responses for risk reduction. That then leads to an implementation plan, and then we're very careful to monitor the progress that's being made and look at how effective that is at reducing risk. There's more that needs to be done in all of those areas. I mentioned some gaps in infrastructure asset data. There are great improvements being made in terms of infrastructure data sets, both in the UK and globally. Satellite data is helping, remote sensing, crowdsourcing, and we're working on that in my team. We need to understand more about the ways in which infrastructures fail, the nature of interdependencies in cascading failure, the economic impact of failure, and how recovery and repair takes place so that we can really understand the resilience of infrastructure systems. But our program is putting together data which is being used in the UK and around the world with the World Bank and others to assess risks and to enable the effective management and improving the resilience of infrastructure systems. I'd have loved to have been able to talk to you all face-to-face about that, but I hope I'll have an opportunity to do that in the future. I wish you every success for your conference and hope that we will be able to collaborate on this very, very important area in the future.
So thank you very much, Mr. Jim Hall. So may I conclude some of key topics, key message from this session. First, from Mr. Van de Guchte from the Netherlands, we learned a lot about, I think, the long-term planning. You are doing something like a next century plan. So that is very good. And one thing is that the wake-up call for monitoring the disaster infrastructure is important. I think we can learn the life cycle of your disaster management very well. And I think the national risk profile that you can put to your national strategy, this is very important. The government committed for a long, long time. That is very important, yeah. And from Mr. Pandya, Secretary General, okay. He talked about, I think, is the hard side, but he wants to talk to the people, ordinary people, to understand the dam. You know, I can recall that when you construct the big dam, the people in the country feel that it is very safe, but when the water level in the dam is very high, the people, many people were very scared of them. So the public awareness is very important for people to understand some civil work of construction of the dam. For Takeya Sensei, you talk about structural and non-structural measures. That is very important for maybe some of us in engineer, we know about the hard side, but we have to know something about the administration and so on. That the administration wants to know some very easy weddings of the engineering construction. So the structural, non-structural measures important. For Yokoyama-san, you brought us to see the ADB work that related to the natural things in each country. That is really important. We may think only the disaster control, but maybe the nature of each country is very different. So we can put it together. And for Professor Jim Hall, the last one, he stresses on the integrated planning for disasters, risk reduction and management cycle. That is so the good conclusion. So the final words that I want to say is that the public awareness is very important for our dedicated work for disaster control infrastructure. So thank you, Chair.
May I just take a few minutes if there are any questions, comments for this presentation? So anyway, so thank you very much for this. We focused on infrastructure, but also the area of coverage extended to policy making, plan making, investment making, and also then integrated approach going beyond, much beyond the urban areas, infrastructure, then the watershed level, water conservation, water preservation, and so on. And I think important message, I think from my perspective, is that advanced countries really making policy and plan investment based on real evidence, and also successfully motivating the political will through, again, clear data evidence of the requirement. But again, from the developing country perspectives, the lack of data is the other constraint. So that poses a challenge. And I think from ADB's work in India, we know that now this urban rejuvenation, urban revitalization is a big topic here. And then I think a lot of urban areas started to do longer term planning process. So in that sense, there's an ample opportunity to reflect disaster aspects in the planning and also financing. Mr. Takeya says.
Thank you very much. According to my presentation, I show the structure measure and non-structure measure. Structure measure is mainly done by Ministry of Construction or Ministry of Agriculture, Irrigation, and so on. But the non-structure measures like a land use plan or something another is operated or managed by another agencies, another ministry. So the leadership of central government, disaster risk reduction and management agencies, most important to take off the barrier of two agencies. So this is one of the Kamaru Kisho-san organized this meeting. Not only the DRR agency, but also the line ministry to take a cooperation together, unless we cannot achieve the target of the Sendai framework. Thank you very much.
Thank you, sir. With this, we partly conclude the technical session 1. I request everyone to kindly join for lunch, and we would reassemble exactly at 2:30.